Welcome everybody to our lesson on quadratic functions, one of the most important functions you'll ever learn how to deal with. You will see an awful lot of quadratic functions in pre-calc, algebra, calculus, physics. They're all over the place, so this is a lesson you really want to make sure you understand. First of all, this is the kind of the most common general form of a quadratic function, ax squared plus bx plus c, where your a, b, and c are your real numbers, and of course a can't be 0 because then otherwise you would just have a straight line, right? This is a slightly less known but very applicable form of a quadratic function. It's the standard form. And the nice thing about this form is it tells you your vertex, right? You know the vertex of your parabola, the vertex of your quadratic function is hk when it's written in this format. So there's your h and there's your k. Again, a can't be 0, otherwise you would just have the constant function, right? Because this would just go away completely. The parabola is symmetric with respect to the line x equals h. Right? We know that parabolas are symmetrical. We know that the basic form of y equals x squared, right? And except for my crappy drawing, you get the idea. It's symmetrical. The minus h here, all that does is it shifts it over to wherever h is. So if it shifted it to the right, then you're going to have a symmetrical parabola centered right here at h. And then all the k does is it shifts it up or down. So you're still centered on that line x equals h. Of course, if a is positive, we know that the quadratic parabola opens up, and if it's negative, we know it opens down. Here's an example of how you can write the equation of a quadratic function in that standard form given some information. So they give you the vertex and they give you a point that it passes through. So the first thing you do is you plug those vertex numbers into your formula, right? You plug -3 in for h and then 4 in for k, and of course when you're subtracting a -3 you end up adding the 3, and all that's left now is a. In order to solve for a, you need one other point. You got to plug in your other point. So that -4 goes in for x, the 7 goes in for y, and you solve for the missing a. Now they didn't show all the steps here, but obviously -4 plus 3 gives you -1, right? And then you get -1 squared times a plus 4. -1 squared is just 1. So then you just get a plus 4, right? These are still equaling 7. And then when you move the 4 over, that's how you get a equals 3, and your final answer in standard form. You can graph a quadratic function very easily if it's in standard form, because as we said, we now know what the vertex is. Because h here, right, it's supposed to be -h, so since we have a plus 2, that tells us that h has to be -2. And this plus 12 tells us that k equals 12. So that's our vertex. Our vertex very simply is -2, 12. The a of -3 tells us that it's going to open down. And now all you have to do is start at -2, 12. You know it's symmetrical. And then to determine how wide or narrow it looks, you can just plug in a point. Plug in an x, solve for y, and then make sure it goes through that point, knowing that it's going to be symmetrical to the other side, right? So we've determined that our parabola opens down because of a equals -3. We've found our vertex. Now we can find our x-intercepts by setting it equal to 0 and solving, and we get, as you work through it, right, set it equal to 0, solve for x, move the 12 over, divide by the -3, right, take the square root, so you know it's plus and minus 2. So you set x plus 2 equal to 2, and you get 0, and then x plus 2 equal to -2 gives you -4, so there's your two intercepts. Next we can find the y-intercept by just letting x equal 0, and we get a a y-intercept of 0. That just happened to be happenstance here. So we know it opens down. We draw our axis line, right? This is the line x equals -2 right here. And we know it's symmetrical around that line. We put in our vertex at -212. We put in our two x-intercepts and our y-intercept, which ends up being the same point. And then from that alone, we can graph it. Good to go. Now, what if we were given a quadratic function that wasn't in standard form? Well, you could always put it into standard form, or you could use other techniques. So it just depends on which you prefer. There are two distinct ways you can graph a quadratic function if it's given to you in the form of ax squared plus bx plus c. The first way is you can put it back into the other standard form, right? You can get it into the form of a times x minus h squared plus k. Put it into standard form. And in order to do that, you just need to complete the square. So if you're good at completing the square, this is very easy. If you struggle with completing the square and you don't like doing that, then you can rely on doing the second technique we're going to see here in a second. But let's just remind ourselves how to complete the square. The first thing you need to do is factor out that 2 and then have x squared plus 4x, and then you're going to have a gap there, and then minus 10. No, this isn't minus 5, because you'll see the 2 is just being factored out of these three pieces, the third piece being yet to be determined, and the minus 10 is out here by itself. Okay, if you don't remember how to complete the square, it's very simple. You take the second term. Well, first of all, you got to make sure that the term in front of x squared is a 1. That's how we factored that 2 out. Then you take your b, right, the number in front of x. You take half of it, which is 2, and then you square it, which is 4, and then all you have to do is add it and then subtract it away, right? Because you want to undo what you've done. Now, in order to take that out, right, we need to get it out of these parentheses. It's really 2 times x squared plus 4x plus 4, and then minus 8. Why is this minus 8? Right, because this is 2 times -4. There was actually a -8 when you bring it outside. And then we still have minus 10. If this seems a little confusing, put the 2 back through. Right, 2x squared plus 4x plus 8 minus 8. Right, and then we're going to, once again, just concentrate on these three pieces, pull the 2 back out, x squared plus 2x, sorry, this is an 8x, which makes this a 4x, right, plus 4, sorry, and then the minus 8 is still on the outside, and when we put the 10 with it, it's minus 18. Now that we have this three-piece polynomial quadratic piece here, we've created a perfect square, and it's just 2 times x plus 2 quantity squared minus 18. And now that we have it back into standard form, we know that h equals -2, k equals -18, and that's our vertex. And now we're right back to where we were before with our first example. We can now set x equal to 0 to find our y-intercept. We can set y equal to 0 to find our x-intercept or intercepts, depending on if we have 1 or 2 or sometimes none. Then we can plot all those points. We know it's going to be symmetrical along the line x equals -2. We know that because of the 2 it's going to open up, and we're good to go just like the previous example. Now, let's say you hate completing the square. You hate to complete the square. You don't like it. It doesn't work for you. You struggle with it. Then forget it. You don't have to do this. This is just if you like to kind of always do things the same way. Then as long as you can complete the square, you get it back into standard form, and then you do everything the way you did it when it was in standard form. But if you don't like doing that, just do this. Starting with your parabola in the normal way that you were given, the ax squared plus bx plus c, and that's the numbers that we had. You need to calculate a very simple formula of minus b over 2a. Then you just have to calculate f of that number, right? Because this is your h, this is your k. So h gives you the x coordinate, and then of course if you do f of x, that's your y coordinate. So that's going to go in, this number here is going to go here for your second piece. So minus b over 2a, very simple. Put in your 8 over 4 with the minus sign, right? Simplifies to minus 2. Then take f of that negative 2. You get 2 times 4, right? Because negative 2 squared is 4. Minus 16 minus 10. So there's your 8 minus 16 minus 10. There's your negative 18. And lo and behold, we get the exact same h and k that we got from the previous example. From here on out, it's pretty much the same thing that we did before. Find our intercepts, if any. So whether we had the standard form equation like we had the first time, or this type of equation, it really doesn't change much. You still set it equal to 0 and solve. Get your two x-intercepts. Set x equal to 0 and solve, and get your y-intercept. Now, plot everything you know. You know the axis of symmetry was at x equals negative 2. You know that you have the x-intercepts that you just found. This idea of it being symmetric, you really only have to worry about this if you didn't get solutions to your intercepts. If you have solutions to your intercepts, it's going to give you enough points that you're going to get the overall shape of your function. If you don't have intercepts, there are the cases where you'll have a quadratic that opens above the x-axis, and then you're only going to get a y-intercept over here, just one, and that's not enough to help you graph. Or you could have one that opens down that's below the line, and again, this is only going to cross the y-axis once. Or even worse, you could have one that's centered on it, so all you have is your vertex. These you have no idea what the shapes are because you don't have a second and third point. You really need 3 or 4 points minimum to give you the overall idea of what a quadratic looks like. If you get those extra points from your intercepts, then you're good to go. If you don't, then you can use these idea of being symmetric around the axis, or just plug in some points. Let x be simple numbers like 1 and minus 1 and see what happens, and 2 and minus 2 and see what happens. Okay? Once you have enough points, just start plotting them. Always start with your axis of symmetry, just like we did with the other example. Then do your vertex, plot your intercepts, and then connect the dots. This was that point that they were talking about, that they know because the distance from our axis of symmetry, which is at negative 2, over to this point, right, that's a distance of 2, then there has to be a symmetrical point at a distance of 2 in the other direction. So that's going to be negative 4, negative 10, right? Same height of negative 10. So that's what they mean by always being able to find the matching pairs. And that's how you can graph them. Either of those two ways, very simple. Last but not least, what happens if we have some word problems? Ooh, the dreaded word problems, or what they call applications of things. So they give you the graph of the function shown below. They want you to find the domain and range of the function, and then they want you to solve the inequality, i.e. they want you to figure out where that function is greater than 0. Well, the domain and range should be pretty easy. The domain of your quadratic, as you can see by looking at it, it goes as wide as you want left and right. So that's going to be a domain of everything. Very simple. All real numbers. Now the range, because it opens down, you know that the range is going to go down to negative infinity, and then it's going to stop at some vertex. So you have to find that vertex in order to figure out what your range is. So you can do the minus b over 2a trick here because it's not in standard form, which gives you negative 8 over 2 times negative 2, which is negative 4. That simplifies to 2. Then you have to plug 2 into this function to actually get the y coordinate. When you plug that in, right, negative 2 times 4, because that's 2 squared, right, plus 8 times 2 is 16 minus 5. So here's negative 8 plus 16. That gives you 8. 8 minus 5, there's the 3 that they got. So there's my vertex of 2 comma 3, and that tells me that the top of my range is 3 with a square bracket because it actually attains that value, and the bottom of my range is negative infinity. Now to figure out where it's greater than or equal to 0, in this case strictly greater than, don't we just need to figure out where it hits the x-axis, and then everything, right, that tells you everything in between those dots gives you a positive, and everything on the outside gives you negatives. So you just need to solve for your zeros. Now, if you set this equal to 0 and try to solve, you'll find out very quickly that it does not factor. You'll have 0 equals negative 2x squared plus 8x plus 5, and you'll try and go, all right, well, maybe let's divide by negative 1 because we don't like to deal with this 2. So positive, negative, negative. You know it's going to be 2x and 2x, and really the only choices you have for 5 are 5 and 1. 5 and 1. So this gives me 10, that gives me 2. Hey, this just might work, right? How about minus 5 and plus 1, right? Because we want negative 10 plus 2 gives me negative 8. So that should work. But what did we mess up? It's not 2x and 2x, it's 2x and just x. So now it doesn't work. Minus 5 plus 2, nope, if you switch them, put the 5 here and the 1 there, then you get x and 1 and 10. So you can't factor. So how did they get these numbers? Well, hopefully you remember the quadratic formula. Minus b plus and minus the square root of b squared minus 4ac all over 2a. And what are the a, b's, and c's? A, b, c, right? A equals negative 2, b equals 8, c equals negative 5. Plug these into the formula, you'll see that you'll have something plus a square root over 2a, right? And then something minus the square root over 2a, and so that's why you get two different answers, plus and minus. Those are your two dots, and you just know that if you're in between though, right, for x's in between those two, you get greater than 0, and they're round brackets because if you equal those two numbers, it equals 0. Okay? Simple, simple, simple. Got to remember that formula. Minus b plus and minus the square root of b squared minus 4ac all over 2a. Very crucial, very helpful. It'll also help you find intercepts for quadratics that do factor. If you don't want to spend the time factoring, you can always just use the quadratic formula. But factoring tends to be faster if you've practiced it a little bit. Let's look at one last example, something that has a little bit of an economics twist to it. So this is a typical kind of word problem. You've got a manufacturer produces X number of items, right, of some sort of of some sort of product at a total cost of 50 plus 2x dollars. The demand function for the product is P equals 100 minus X. They want you to find the value of X for which the profit is a maximum and how much is the maximum profit. And they give you a little hint to remind you that profit equals revenue minus cost. All right, so we have to come up with both of those functions, cost and revenue. Well, our cost function is easy because they give it to us right there. It's just 50 plus 2x. But what about our revenue function? Well, this is not our revenue function. That's our demand function. That's the demand for the product, right? To find revenue, you've got to do demand times number of items. So that's going to be x times 100 minus x, which is 100x minus x squared. That is our revenue function. So now our profit function, right, we'll call it capital P of x, that's revenue minus cost, just like they told us up here, and that's 100x minus x squared minus our cost function, which is 50 plus 2x. Distribute that through, right? 100x minus x squared minus 50 minus 2x. Clean it up. Negative x squared plus 98x, right, because there's 100 of them, minus 2 of them, minus 50. There is our profit function. Now, what does that look like if we graph it? Hopefully you're all recognizing, well, that's a quadratic, and because there's a negative sign there, it opens down, right? So we're going to have an upside down parabola, which is going to have a maximum at the vertex, right? So all we have to do is find that vertex. You can use whichever technique you like. You can either complete the square and put this in standard form, or, which I think is a little easier, just do the minus b over 2a technique. So minus b, negative 98 over 2 times negative 1, right? Because a is negative 1. So this is negative 98 over negative 2, which gives you, very simply, positive 49. Now all you have to do is figure out f of 49. And in fact, we've already solved half of it because it said find the value of x for which the profit is maximum. That's what we just found. And how does this relate back? So x equals 49 is where we maximize our profit. What does that mean? That means they should produce 49 items, right? 49 units. And then f of 49 means if they produce 49 units, what's their profit? So you're plugging in 49 squared, right? Negative 49 squared plus 98 times 49 minus 50. Crack out your calculators, do the work, and you get that your profit equals $2,351. And that's it. That's the maximum profit we get if we produce 49 things.